Dear colleagues, I'm going to speak about the applications of remote sensing made from UAVs. In fact, I chair the University Center for Space Research and Technologies, but we also use a lot of UAVs now because they are extremely efficient. I mean that you may achieve incredible results with a very low cost relatively to satellite missions. And the other advantage is that they are very express. You can observe forest fire or whatever immediately when you need, but satellites have a very big obstruction because you cannot see the Earth's surface when it's cloudy. So satellite data are first with low resolution, second are with very few images in time. You cannot follow one event from satellite. You can make just one observation normally. And the last very important application is when we develop some sort of equipment for observation. For example, from satellites we must test it on Earth. And the cheapest testing facility are UAVs like this one. In fact, this is UAV developed by the company of Union. And in fact, we have many applications. They are separated in two types. One is observation, and the other one is measurements. Both can be done by this kind of instruments. And when your plane is flying close to the surface, you may get incredible resolution. But other airplanes, which are high altitude airplanes, can have longer flights, like this one, which can fly up to 48 hours. Now, several applications. These are observation of different parts of the surface of the Earth made from UAVs. These are three pictures in different regions of spectra, and this is normal picture. This is near infrared at 710 nanometers, and this is 810 nanometer picture. Now there are many applications for forest fires, for forest drying. For example, this kind of photos can show you places on forests which are damaged by drying, for example, because these combined images give you directly the degree of wetness of the forest. Normally, red color is attributed to infrared, and normally in this kind of pictures you can see the red spots are dried parts of the grass or of the forest, which is very important because you can predict forest fires where they will happen. You also can estimate the gain of the grain, for example, making such photos. And these are applications for study of mines. In fact, 3D models are very useful for this kind of applications. This is 3D model, in fact, of mine. Here you can see the development of mine. You can study also pollutions on these pictures. You directly see places which are polluted. And this one was done in the previous year, and this is in the now. And you can see the difference of the pollution. In fact, this lake is polluted by waters coming from ores. You know, when you have exploration of ore bodies, they normally produce sulfuric acid, which here enters the lake. This is due to oxidation of sulfide minerals in ore bodies. Now some other applications. Here you can see forest fire in infrared. And this is the same region but in normal picture. In fact, in normal picture you can not see and you cannot locate the forest fire due to the smoke. Smoke is much better visible in normal light than in infrared. Here you can see directly heated areas due to forest fire, and this is very useful and efficient for fighting of the forest fire, because you will know exactly where you must drop the water in order to quench the fire. Now this is using of UAVs for 3D models of various buildings. This is how we can make 3D model of this castle with the UAV. This is a very interesting project. In fact, 3 years ago, International Union of Speleology started a new very interesting project for locating caves from UAVs using thermal vision cameras. Here on this picture you can see a cave entrance, which is taken from normal airplane. This is thermal vision camera image. Here you have scale in degrees Celsius. And the idea is that temperature inside the cave is equal to the mean average annual temperature of the region. And when it is cold outside during the winter, hot air is coming from the cave entrance, and you see here actually the hot air coming from the cave entrance. Well, it looks quite crazy, this kind of application, but this is extremely important for space exploration. In fact, studies of caves now are extremely important for explorations on other planets, like exploration on Mars. There are 3 different fields where we use caves for space exploration. The first one is cave microbiology. Cave environment is extremely similar to the space environment. So in fact, the new director of NASA Astrobiology Institute is cave microbiologist. I know this young person. And the second field, which is very well developed, is training of astronauts inside of caves. This experiment started in the 70s because the cave environment is very similar to the space environment. And this is the last development in this field, which was my idea. In fact, and I proposed one international program of the International Union of Speleology, and they started the program. And here I will show you just a couple of seconds moving the announcement of the program. Here is the announcement of the program. We don't have sound here, but never mind. The idea is first to make calibration of the method on the surface, looking for caves with thermal vision cameras, then to mount these cameras on UAV, and to locate new caves on Earth and to calibrate the method on caves. Then the last stage is search for caves on Mars. Why we need caves on Mars? We need them very hardly because, first of all, space is extremely dangerous for any astronaut. This is not very well discussed and announced. You cannot see this on science fiction movies, but cosmic radiation is extremely deadly for any person in the open space outside of the magnetosphere of the Earth. In fact, we are protected by the Earth atmosphere and by the Earth magnetosphere. That's why cosmic radiation is not affected us very badly. But this radiation is very deadly for astronauts, and especially on the surface of other planets. So when they reach Mars, if they will be still alive, which is under question, they must hide somewhere, not on the surface of the planet, in order to survive. And the best places to hide on early stages of exploration of Mars is to hide in caves. There are caves on Mars, and NASA even believes that these famous channels on Mars are produced from water coming from huge caves located under the surface of the planet. So the last stage of the project is to mount thermal vision cameras on space missions on Mars, on automatic apparatus, and to observe the surface of the Mars and to locate these caves on Mars. Now, here you can see infrared picture of one piece of the desert in Egypt. Ognan just told you about this. This is a huge city which is not visible in normal light. This is a normal Google Earth picture of the same region. And in infrared, you can see that you can directly see many structures, many pyramids were located by this way and so on. Now these are different applications. These are studies of the solar corona using various photographs which we made. Now, this is a magnetometer picture of one archaeological structure. This is something like a map. And this is a ground-penetrating radar, GPR, so-called picture of the same image. In fact, ground-penetrating radar can give you the depth of the facility, while magnetometer can show the surface of the facility. And now we have one project to mount such devices on UAV with Ljubljana, which is undergoing, and in fact there was very successful experiments using normal copters. This is ground penetrating radar antenna here. And here they use this device to locate underground tunnel and to study different structures underground. So this can be done in the future. And this is another our project to locate oil, especially oil spills, but not from the ships, from nature of oil on the surface of the water, using luminescence of the oil. These are crystals of calcite, and this blue luminescence spot here and orange luminescence here are oil inclusions inside the crystal. And in fact, oil in very low concentrations can be detected using this phenomena with such kind of detectors. This is detector for fluorescence of oils, especially. And we intend to mount this kind of detectors on UAVs in order to locate oil. And in the end, these pictures are again of our colleague Tom Filippo from the Center of Aerial Surveillance in the Faculty of Geology and Geography. And here you can see one normal image of the area, and this is a composite image. And here you can see several clouds. Some of the clouds, this is normal cloud, which is very cold region. In fact, this is thermal vision photograph. This is something like ice carrying cloud. And another one, this one is technogenical pollutions, which are indicated here. This one looks like, see, have very special geometry. It looks like smoke coming from a certain spot in Bulgaria. It has specific morphological structures like semi-transparencies, and they look like, especially like a flame. And their temperature is higher than the temperature of the atmosphere due to the clouds. In fact, this cloud is due to some sort of technogenic pollution of a forest fire or whatever. And now this kind of copters are used for measurement of chemical pollutions. And also nuclear pollutions. And this is a map of pollution of Japan due to the nuclear accident which happened there. And this map is made completely by aerial measurements from UAVs. Programs. These are images of the space station taken from the Earth, and this is a model image. We intend to use such observations to observe the space debris. It's also another possibility. And thank you for your attention.